Okay, this will be our next example for your vector and scalar addition. A GPS receiver told you that your home was 15 kilometers at a direction of 40 degrees north of west, but the only path led directly north. So if you took that path and walked 10 kilometers, how far and in what direction would you then have to walk to reach your home? It's your choice if you would choose your graphical or component method in this one. Okay? So I will show you the graphical and your component method. You may check it using your calculator method. Okay? So first, let us analyze a problem by drawing our Cartesian plane. Okay? So this will be my Cartesian plane. Okay? And then by after drawing your Cartesian plane, let us uh name our y and x coordinate, which is we have our north, east, west, south. Okay. So according to the problem, our home is 15 kilometers north of west. So 40 degrees. This considering this one, so this is our home. Okay. Which is 40 degrees northwest. And then we have our 10 kilometers north. So you will go up north for 10 kilometers. And this is the magnitude of this vector is 15 kilometers. So what is your analysis? Take note that at 0, 0, this is your position. Okay. And then this is your destination, your home. So this side, this is your home. So how will you solve this one? Considering that your destination is at 15 kilometer, therefore I will say that our dr or your resultant displacement is equal to 15 kilometer angle of 40 degrees. And our d1 is equal to 10 kilometer angle of 90 degrees. This take note that this 40 degrees is northwest. Okay, which means that your dr is equal to 15 kilometer. Considering your clockwise direction will have angle of 130. So if you would input it in your calculator later on, we have dr is equal to d1 plus d2. So your arrows, considering that they are vector. So we have our dr, which is 15 kilometer angle of 130 is equal to d1, which is 10 kilometer angle of 90 plus d2. You may solve that one by subtracting your dr and your d1. Or take note that if you are subtracting, you are still adding kasi pwede mong gawing negative yung isa and then i-add mo. Right? So, in vector. So, next, I will analyze this one using my parallelogram law simply by projecting the forces, but taking my dr as our resultant force. So if our dr is our resultant force, so by tip to toe rule, I will draw my tip to toe which is basically this will be my d2, which is unknown. Okay, so will we solve for your d2? Of course, using your cosine law. Doon lang tayo babalik sa cosine law. So first, let us identify this theta. Wherein, you all know that this theta, by calculation, solving for dr, solving for d2, or the magnitude of d2. Okay, you all know that your theta is just equal to, this is 90 degrees, so complementary yan, 90 minus 40, therefore it is 50 degrees. Pag supplementary, 180 degrees. Pag complementary, 90 degrees, right? So, your theta is equal to 50 degrees. Next is solving for our d2. So, take note that your d2 is directly opposite to your theta. And then, we will solve for your d2 directly. Okay? So, you'll have your d2 is equal to square root of, from your cosine law, d2 is equal to dr squared plus d1 squared minus 2 dr multiplied by d1 cosine theta, wherein our dr squared is equal to the magnitude, which is 15 squared, plus our d1 squared. This is the magnitude of your d1, d2 squared, d10 squared minus 2 multiplied by 15 multiplied by 10 multiplied by cosine. Solving for the value of d2, so you will have square root of 15 squared plus 10 squared minus 2 times 15 times 10 cosine theta, which is 50 degrees. So we have a value equal to 11.496. The magnitude of your d2 is 11 kilometers. So this is the answer for your d2. So that your theta was substituted from that. So how will we solve for your alpha? Let's say this will be your alpha. Okay, so your alpha can be solved using silo, solving for alpha. So using our, notice that you will use your d2 all over sine theta, d2 all over sine theta, because your d2 is the opposite of the angle sine theta, and it is also equal to your dr all over, dr is the opposite of your sine alpha, dr sine alpha. Solving for alpha, we'll have alpha is equal to sine raised to negative 1 dr sine theta all over d2, which is basically equal to sine inverse or arc sine times your dr, which is equal to 15 kilometers divided by d2, which is 11.5 kilometers or 11.49 kilometers. 11.4962 kilometers. So cancelling out your kilometers because it will be equal to 1 multiplied by sine theta, which is 50 degrees. So getting the sine inverse of this one, so we have shift sine 15 all over 11.4962 times sine 50 So we'll have a value equal to 88.22 degrees. This is the value of your alpha. Okay? So since that is the value of your alpha, do you think that this consideration is possible? Kasi pag tinignan mo, yung kanya, yung lawak ng pagbuka ng alpha, it is more than 90 degrees. So therefore, we will reassume your alpha. So since mas maliit yun ng 90 degrees, ang gagawin natin is itataas natin siya. Okay? So I will redraw the Cartesian plane. So this time sa baba tayo. Okay? Okay? So this will be our 15 kilometer. This is 40 degrees. And then, so we'll have your 10 kilometers. So tataasan na natin siya konti. 10 kilometers. Okay? So, this is our T1. You can see that it is lesser than 90 degrees based on the calculated alpha. So, this is 88.22 degrees, which is equal to your alpha. And, syempre, this is your 50 degrees. So, what would be the direction of your D2? So, by getting the its position below the x-axis. So, I will project my x-axis upward. Okay, so take note that this is your y and x. So, I will project this x-axis up in order to get the angle or the direction of my D2. So, I will consider it as your beta. Okay, therefore, how to calculate my beta? So, using your complementary principle, so they are complementary angle, your beta and 88.22 degrees. So, we have 90 is equal to beta plus 88.22 degrees. So, therefore, my beta is equal to 90 less 88.22 degrees, which is particularly equal to 1.78 degrees, approximately equal to 1.2 degrees. So take note, 1.8 degrees. So take note that some of your calculation will be lesser or higher at decimal points. It depends on how you will use the data, if it would be stored or round up in a significant values. Okay. So this is the graphical solution for your example number 2. If you want to use your component method, the answer should be the same. Okay.